Alright, so we're in the car right now. The project's due it tomorrow before class. Have I started it? No, I have not. Am I gonna do it? Yeah, probably. But first, I'm gonna get some Taco Bell because I'm a responsible student. It's 3:45 in the morning. I'm surviving off of energy drinks. I'm really excited for this project, and I have a final first block before it. Okay, let's go. Internally, Earth gets its energy from when it was formed. Frictional heating caused by denser core material sinking to the center of the planet and heating from the decay of radioactive elements. Heat is the transfer of energy between systems, which leads me to the question, how is energy transported through the geosphere? Radiation, conduction, and convection. And Parkhill said, don't just say radiation, conduction, and convection, tell me what they are. I would never let you down, Parkhill, even though you won't bump me up to an A. Radiation. A major source of Earth's heat is radioactivity, the energy released when the unstable atoms decay. The radioactive isotopes uranium-235, uranium-238, potassium-40, and thorium-232 in Earth's mantle are the primary source. Conduction. Heat is transferred as atoms collide. An example of conduction is a frying pan over an open camp stove. The fire's heat causes the molecules in the pan to vibrate fast, making it hotter. The molecules collide with each other, which makes the pot hot. The same thing is happening on a larger scale in the Earth's mantle. Convection. When the mantle convects, heat is transferred through the mantle by physically moving hot rocks. Mantle convection is the result of heat transfer from the core to the base of the lower mantle. Heat rises and the cold material goes down. The primary source of energy for the atmosphere is the sun. And how does the energy move? Of course, it's radiation, convection, and conduction. Conduction. Sunlight heats the ground and it conducts, which heats the air. The hot air then convects and rises. Radiation. Energy is released by the sun in waves. When it reaches Earth, some is absorbed by the atmosphere and some is absorbed at Earth's surface. Now, onto my energy source of choice, tidal barrages. A tidal barrage is a type of tidal power generation scheme that involves the construction of a fairly low-walled dam that spans across the entrance of a tidal inlet, basin, or estuary, creating a single enclosed tidal reservoir. The barrage has multiple underwater tunnels cut into its width, allowing seawater to flow through them in a controlled way by using sluice gates on their entrance and exit parts. Fixed within the tunnels are huge tidal turbine generators that spin as the seawater rushes past them, either to fill or empty the tidal reservoir. The water that flows into and out of these underwater tunnels carries enormous amounts of kinetic energy. Kinetic energy that is collected is part of the process of conduction. Woo! Okay. The pros of tidal barrages are that it's renewable, obviously. There's zero carbon emissions because it doesn't produce a greenhouse gas. It's predictable because tides and currents can be forecasted accurately. The cons of tidal barrages are there's limited installation sites. They need to be built in places where difference in height between high and low tide is significant enough to power turbines. It's also quite expensive. It costs $3 to $15 million to build a tidal barrage on a normal scale. Also, the environmental effect. As turbines spin, fish and other sea life could swim into the blades, causing serious injury or death. Barrages also act as dams that cause local flooding and prevent the migration of fish. The Siwa Lake Tidal Power Station in South Korea has the largest electricity generation capacity at 254 megawatts. That's my example of a tidal barrage because it's actually the largest one in the world. It is 12.7 kilometers long and it was made in 2011. It cost $298 million to build and it produces over 550 gigawatts per year. To put that in perspective, 1 gigawatt can produce enough electricity to support 750,000 homes with air conditioning running at all time. All right, that's the end of my project or whatever. I'm going to bed.